Hey everybody, Dr. A here, and in this video we're going to be exploring another axial load example. So given to us, we're being told to draw the axial load diagram. And here we have an axially loaded bar that is subject to a uniformly distributed axial load of 3 pounds per foot, and the whole bar is 4 feet long. And at the left end, we have a fixed connection. I'm going to go ahead and give this fixed connection a name. I'm going to call it A. All right. So under solution, the first thing we're going to do is compute the external axial reaction. And if you've been watching the previous videos, you know that we have one applicable equilibrium equation for an axially loaded system, and that's the sum of the forces along the axis of the member should be equal to 0. So in this case, we're going to say sum of the forces in the x direction should equal 0. And so if we draw a free body diagram of this system, we're going to have the member here. And on the left side, we're going to have AX. And along the length of the member, we have that uniformly distributed axial load of 3 pounds per foot. Sometimes that shows up as 3 PLF. If you ever see PLF, that means pounds per foot. We have 4 feet here. So when we apply this equilibrium equation, sum of the forces in the x direction equals 0, we're going to get AX minus 3 pounds per foot times 4 feet equals 0. And we'll get AX is 12 pounds, and it is pointing to the right. And again, it's pointing to the right because when you rearrange this equilibrium equation, you're going to get a positive 12. The other reason, you can just think about it, if the applied load is all pointing to the left, then the reaction has to counteract that and be pointing to the right. So you can think about it from a physical sense as well. So that's our axial reaction. Now, do we have an AY or an MA here? Yeah, sure, but they're both 0 because this is a purely axially loaded member. And if you're a little shaky on why that's 0, check out my previous videos on this topic because I explain it in more detail in my previous videos. So let's go ahead and draw the axial load diagram. Make our axes like this. I'll call this F. I'm going to call this X. This has units of feet. F has units of pounds. I'm going to say forces pointing to the right are positive. So the first thing I encounter on the left side here is AX, and it's 12 pounds pointing to the right, which means that I'm going to start up here at 12 pounds, okay? Then what do I encounter? I encounter this uniformly distributed axial load. This is not a single force now. This is a uniform load. It's just spread out along the longitudinal axis of the member. And it has a magnitude of 3 pounds per foot, okay? What that means is at a rate of 3 pounds per foot, that axial load is decreasing as we move from left to right. One more time, think about that. As we move from left to right, that axial load is decreasing at a rate of 3 pounds per foot, okay? So here's what we're going to do. We're actually going to sketch this as a linear graph. It's going to look just like this. Nice and linear, okay? Where this value right here is 4 feet, all right? Now, how do I know it's linear? Well, again, this uniform load, it's a rate of change. It means every linear foot of this member is decreasing or experiencing 3 pounds to the left, okay? So it decreases linearly, and as you saw in one of my other videos, we sometimes like to shade this here. And that's it. That is our axial load diagram. So if you found this video helpful, please hit like and subscribe, and please be on the lookout for other videos like this one. Thanks for watching.